This video is to help explain discrete versus continuous data and how to determine if a situation represents discrete or continuous data, and then also how to think about what the x and y values, what numbers would make sense for the x and y values. So the first situation I want to talk about is a graph for just y equals 2x, where x is the number of pounds of rice scooped and purchased from a bulk bin at the grocery store, and y is the total cost of the rice. So you want to think about what x could be and what y could be. So can you use all positive and negative values here? Can you have a negative number of pounds of rice scooped out of the bin? And can you have a negative cost? Are you gonna go to the grocery store and be charged a negative amount, meaning they're gonna pay you for your food? No. So in this situation, negative values do not make sense. So then we need to determine, well, we know they're all gonna be positive values, but is it gonna be just specific points only, or do the numbers in between the points make sense? So like, if we create a table of values, we could have 0 scoops and pay $0. We could have 1 scoop and pay $2. We could have 2 scoops and pay $4. Well, that we know makes sense. Now think about, what about 0.5? Do you think it's possible to have half a pound of rice and then pay $1? Or what about 0.75? Could you have a quarter of a pound of rice and pay $1.50? Could you have 1.5 pounds of rice and pay $3? When we talk about pounds of rice and scooping it out of a bin, we don't necessarily have to have just whole numbers. We can also have all the numbers in between. So if I was going to make a graph of this, I would start at 0, 0, showing that I would not have negative numbers, but then I would connect the points so that I can see that everything in between 0 pound and 1 pound is still a quantity that makes sense with this situation. So for this problem, it is continuous. So I would draw the line. It's continuous because I can continue between the whole numbers, and those numbers make sense with the situation. Let's look at some other situations and determine, do we think that these situations represent discrete or continuous data? Juan ate an egg with 78 calories and some cereal with 110 calories per serving. When you eat cereal, do you measure the amount of cereal you eat in number of servings? Meaning, can you have only 1 serving or 2 servings? Or do you think it's possible to have 1.5 servings or 1 7/10 of a serving? It is definitely possible to have serving sizes in between 1 and 2 servings. So this would be continuous data because it continues beyond just the 1 and 2. It continues between whole numbers. All the numbers greater than 0 for the number of servings makes sense. So just because you say it's continuous doesn't mean that it has to continue forever in both directions. We can still limit this to say we're not going to use negative numbers, but it's still continuous on the positive side of the graph for the number of servings. All right, another example, the yearbook club has 5 members returning from last year. They set up a booth in the cafeteria to recruit more members, and an average of 3 new members sign up each day. Which best describes why the graph relating the total number of members on the yearbook club M and the number of days the booth is set up D will be continuous or discrete? Well, let's think about this. We have people. So we could have 3 people join after we have at the start of the year, so X is number of days, at the start of the year we have 5 members. Then it says, okay, well, each day they have an average of 3 new members. So after 1 day of being in the cafeteria, we add 3 members and we have a total of 8. After 2 days of being in the cafeteria, we have 11 members. After 3 days, we have 14 members. Is it possible that a day and a half we're going to have 9.5 members? Do you want to be half of a member? Anytime you talk about the word members or people, anything that relates to people will be discrete, because you can't have half of a person. So that's what we mean by the numbers in between do not make sense, because you're not going to have half a day go by with 1.5 people signing up. So it is limited to just the points that we're plotting here. You can have half a day, but you can't have half of a person. And another example, a store sells notebooks for $3 each and does not charge sales tax. X represents the number of notebooks. Can we buy negative notebooks? No. Can we buy none? Yes. Can we buy half a notebook? No. I've never been to a store and bought a notebook and said, well, I only want half of this. Can you take half the pages out and sell it to me for half the price? I do not think that that would go for that. So we can have 1 notebook, we can have 2 notebooks, we can buy 3. So my X values can be integers greater than or equal to 0. I wouldn't use the real numbers to describe this, because the set of real numbers includes all rational and irrational numbers. And rational numbers includes all fractions, decimals, and integers. So we need to be more limited here and say, well, because you can't buy half a notebook or 1.5 or 1 2/3 of a notebook, we can only use integers greater than or equal to 0 for X. And because what we're using for X and Y is dependent on X, cost is dependent on the number of notebooks, we can only have integers greater than or equal to 0 here, because the cost is $3 each. So that's not going to change. So I would describe the X and Y values here as integers greater than or equal to 0. Hope that helps. Thank you.